Hello all, let's finish the rest of section 4.1 which we discussed exponential functions. Here in this video I'll just explain to you and I'll do a lecture on the last part of section 4.1. The first thing that I want to discuss here with you is the natural base e. The natural base e, or in a simple language, here I want to introduce to you what is number e, correct? Number e is a decimal number which the value of e is equal to 2.7, approximately I can say 2.71. There was a mathematician by name Euler, a German mathematician, and somehow in German language they're writing Euler with the E. He is the man that actually he found the natural number E, correct? And because of that, they named this number E because of his name. Or some people say because it's an exponential number, we call it E. But anyway, the value of E is equal to 2.71. But how we get this? Actually, your E is equal to 1 plus 1 over n to the power of n. Here, as your n is increasing, is approaching to infinity, correct? Your e is coming closer or approaching closer and closer to 2.71. It's really interesting. If you plug in here different numbers, for example, first time plug in n1, next time plug in n2, next time plug in n3. Let's do few of them. For example, e equals 1 plus 1 over, I'll plug in n1. 1 to the power of 1. Then e equals 1 plus 1 all to the power of 1, which gives you e equal 2. Next time, if I put n equal 2, and if I plug to this equation, it gives me 1 plus 1 over 2 to the power of 2, which gives you 1 plus 1 to the power 1 half gives you 1 half, or I can say 3 halves, right? 3 halves to the power of 2. And if I square this, it gives me 9 over 4. And if you divide 9 by 4, it gives you 2.25. You see the first one is 2. As n is approaching to positive infinity, this number is approaching to 1, to 2.71. Next time, if you plug in here, for example, n equal 10, correct? You will see when you plug in n equal 10, your e will become 2.59 if you calculate, right? I don't want to do this calculation for you. Just know that what is number e? What is natural number e? Number e is a very interesting and important number when we are dealing with exponential functions. Some of exponential functions, they are in the form of f of x equals e to the power of x. This is one of the main exponential functions that soon, if you go to different levels of mathematics like upper division, we will discuss this number there really in detail. But right now, just understand what is the value of number e. The value of number e is 2.71, correct? The next topic that's discussed in your book is compound interest. What is compound interest? When you have some money, correct? Which here we call it principal. When you have an amount of money, which we call in this topic principal, your principal money. For example, I have $5,000 extra, correct? And you want to invest this money in a bank, correct? In a fixed rate, correct? Your principal money, P, in a fixed rate of R, correct? Rate, which here we represent with R. For example, the bank gives you, oh, we give you like 7% interest. For a limited time or fixed period, correct? Which we call it time here. For example, oh, and time represents in the formula T, correct? For example, for let's say 5 years. And the bank will say to you that they will compound your money, and they give you different options every month, quarterly, semi-annually, yearly, correct? Or maybe even daily, correct? Which here N represents the number of compounding periods per year. Let me put first here number of compounding period per year, correct? Periods, let me clean this, per year, which represents N, the money that after 5 years or after that time period that you invest your money that you are receiving, we call that one a compound interest, correct? And the main formula that you are using now in this topic is A equals P parentheses 1 plus R over N to the power of N times T. We call this formula the compound interest formula. Compound interest formula. The proof for this formula is in calculus 2. I don't want to prove it here. Even I don't want to prove this formula for you in pre-calculus, even not in calculus 1. The proof for this formula from where we can write A equals P times 1 plus R over N to the power of NT, the proof is in calculus 2. But here in this book, we just memorize it as a compound interest formula. I already introduced the symbols or the letters that we used in this formula and their meaning. A is the amount that you received after after compounding, correct? P is your principal money. R is the rate. N is the number of compounding periods per year. And T is time, correct? Now, some words that you may see, because we are dealing here with applications, some words and their meaning. First, semi-annually or semi-annual. Compounding semi-annual. It means you are NS2. Correct? Quarterly. It means you are NS4. Because 1 year, if you divide 1 year, it gives you 4 quarters, correct? Monthly means you are NS12. And daily, it means you are NS equal 365. Correct? Annually, annual means 1. It means you are NS equal 1. Correct? These are the words that you may see when we are solving the compound interest problems. Correct? Don't tell like, oh, the problem is here, they don't give me the n. How much is n? They will use one of these words for you. Annually, semi-annually, quarterly, monthly, or daily. And you should know, annually means n equal 1. Semi-annual means n equal 2. Quarterly means n equal 4. Monthly means n equal 12. And daily, n equal 365. Correct? Let's discuss first the compound entrance. Then we will go to another formula which we call it continuous compounding. Correct? But let's do a few examples for this formula. Example number 1. I don't want to write a lot here, but I'm making an example, just listen. A parent, they have a kid and they want to invest for him $5,000 in their bank account for 20 years. Correct? They are a good parent. They want to invest something for their kid or for their baby, which is a newborn baby, and they want to invest some money and say, okay, when he or she become 20 years old, he will have some money, correct? They want to invest $5,000 in a bank. They go to the bank and the bank gives them a rate of, let's say, for example, let's give them a good rate, 8%. Correct? And the bank will say, we are compounding your money semi-annually or semi-annual. Correct? Now, we want to find after 20 years how much this kid or that boy or that girl will have in his account. Correct? It means we are looking to find A, the money after compounding in 20 years. Look, in this example, what's given? $5,000 is the principal money that the parent want to invest in the bank. Correct? Time is 20 years. Correct? The rate is 8%. And you know from mathematics, every time that you want to use percentage, you have to change the percentage sign to a decimal. 8% means 8 over 100, or in an easy language, 0.08. You cannot use this number 8% in the formula. You have to change it all the time to a decimal or a fraction number. Usually we prefer to use a decimal number because in these problems we usually use calculator. Correct? N is given semi-annually, which means 2. Correct? Now I'm looking for A. How much will be in the account after 20 years? Our formula is A equals P times 1 plus R over N to the power of N times T. Let's plug in the values. Then A equals P, which is 5,000, times 1 plus R. Your R is 0.08 over N, which is 2, to the power of N, which is 2, times T, which is 20 years. Now, with different colors, I will show you the steps where to start working with these numbers. Some people, they do this huge mistake. They want to multiply this 5,000 first year. Wrong, I cannot do that. Actually here, what we do, we follow the order of operation, correct? I'll just show it to you. Again, which part you have to do first. Your first step is to multiply these two numbers. And if you wish, you can do this division, also this one. Let me go step by step. I don't want to do 2 steps in one. First thing to do, multiply these two numbers. Then you can write A equals 5,000 times 1 plus 0.808 over 2 to the power of 40. 2 times 20 gives you 40. That was your step 1. Even let me put here 1, step 1. Now, step 2, you have to simplify this fraction. Correct? This is your step 2. Then A equals 5,000 times 1 plus, let me open a calculator here. It should gives you 0.04, right? But let me show you in a calculator. Here you see 0.08 divided by 2, which gives you 0.04, right? Then 1 plus 0.04 to the power of what? 40. Now, where to deal with? Your next step, add this two number, please. This is your step 3. Then you can write A equals 5,000 times 1 plus 0.04 gives you 1.04 to the power of 40. Correct? Now, step 4, raise this number first to the power. That's your step 4, correct? Then you can say A equals 5,000 times, let's raise this number to the power of 40. Again, calculator. 1.04. Look, in your calculator, you have x to the power of y, or you have y to the power of x, or x to the power of an empty box. That is raising this number to the power, correct? I'll push this button and I'll write 40, which is equal Wow, look at this decimal number, correct? Look at this decimal number. 4.801020627936650273820, and still it's continuous. You may think here that, okay, it's a very long decimal. I will round off and I'll write this as a 4.9. No, please do not do that. If you are working in a bank and you round off the number here, people can sue you. You can lose your job. Correct? Because it's a lot of money. Even the last digit, which is 6 after decimal, it's really a small amount. You can't see even that one. But when it comes to a big account, big money, it creates a lot of money, right? You cannot round off in this stage. That's why I didn't close the calculator. I don't want to write the number there. Immediately after you raise the number to this power, multiply it with your principal money times, my principal money was 5,000, correct? And equals now 24,005.10. A equals 24. What was the number? 24,005.10. Correct? And the last step, yes, go round it off because it's the last step, and after the decimal it shows cents. Correct? You are allowed to do round off in your last step. Now, how much money is this? This one is actually $24,005.10. You see, when the kids becomes 10 years old, that kid will have this much money in the account. If the parent invests 5,000 with a given rate in the bank for 20 years. Correct? We call this topic the compound interest. There are some examples also in your book that you can practice with. The next formula that I want to give it to you is continuous compounding. Continuous compounding. In the previous lecture, we just compounded annually, semi-annually, monthly. But in this topic, we are talking about continuous compounding. Correct? Some banks use continuous compounding. It means that the number of compounding periods increases infinitely. Correct? Now, the formula for continuous compounding will be A equals P times E to the power of R times T. Correct? We call this formula continuous compounding. I'm not going to do an example on this formula because I will not include this formula in your test, but it's really easy to understand that still you have your principal money, which is P, still you have the rate, and still you have the time, how many years. Instead of 1 plus R over N, instead of this, now they are using E. Correct? Because I just introduced number E to you as a base. But anyway, we are leaving this formula for future. Just the topic of discussion today was the compound interest and using the formula, which I did an example for you, and I gave you all the steps how to deal with the numbers, correct? How to simplify that formula. And hopefully you will do 1 or 2 more examples or your homework at home and you will be okay with this topic. I will stop the lecture here and see you all in section 4.2.